Picture our world without ice cream. No frosty treats to cool us down on a hot summer day. But even worse, what if all the ice at the poles melted? Would we still have a world to live in? Welcome to my channel. And today, we are answering one of the great polar-based what-ifs. What if all the ice at the poles melted? Earth's polar regions are covered in ice. The frigid temperatures and high altitudes of the North and South Pole lead to the formation of glaciers and ice sheets, massive bodies of ice that can last for thousands of years. At the North Pole, the Arctic ice cap is 4 kilometers or 2.5 miles thick. In the South Pole, Antarctica's ice sheet is almost 50 times thicker than the Arctic ice cap, with an average thickness of 1.9 kilometers or 1.2 miles and reaching a maximum thickness of 4.8 kilometers or 3 miles. This means that there is far more frozen water locked away in Antarctica than at the top of our world. In total, the two poles store about 66 million cubic miles of fresh water in ice form. That's around 2.75 quadrillion gallons of frozen water. So just how much water is in all the pools in the world? That's about 13 quadrillion gallons. We're talking roughly 5 times as much water as is stored in all the pools on Earth. But the water locked up in these ice sheets hasn't always been there. It's not some ancient, never-before-seen body of water. Both the Arctic and Antarctic regions had liquid water bodies until the temperatures dropped below freezing. And it's this drop in temperature that will have such catastrophic effects on the rest of the planet if the ice melts. If all the ice from both poles melted, global sea levels would rise by over 60 meters or 200 feet. For perspective, the current average depth of the ocean is about 3,688 meters or 1,200 feet deep. This means that if all the ice at the poles melted, we'd be adding another 1.5 Hiroshimas piled on top of the ocean every second for 500 years. But would the water just appear out of thin air? How does melting ice raise sea levels? As ice melts, it transitions from a solid to a liquid state. While frozen, the water molecules in ice are locked in place and form a rigid lattice structure. However, once the temperature rises above freezing, the molecules gain kinetic energy and break free from their bonds. As a result, water becomes less dense in its solid form than in its liquid form, which is why ice floats. This also means that the volume of water increases when it melts because the molecules are no longer confined to a fixed structure. Imagine packing a bunch of balls into a box. The space between the balls represents the area taken up by the bonds holding the ice together. When the balls become loose, the space between them increases, meaning that overall the box takes up more space. The water from melting ice eventually drains into the ocean, adding to its volume and raising sea levels. However, not all ice melts into the ocean. Some of it makes its way into rivers and groundwater, but the majority ends up in the sea. One study found that around 90% of ice loss from Greenland, the largest island on Earth and the home of the second largest ice sheet in the world, flows directly into the ocean. The remaining 10% makes its way through rivers and groundwater into the North Atlantic Ocean. When the ice hits the ocean, it doesn't immediately raise sea levels where it melts. Currents move the water away from the poles. For example, the Gulf Stream carries warm water from the Gulf of Mexico up towards Europe, while the Kuroshio Current carries warm water from the tropics towards Japan. But the Gulf Stream slows down and weakens when fresh water from melting ice enters the ocean. A similar phenomenon occurs at the South Pole, where the Antarctic bottom water, one of the most important deep ocean currents in the world, slows down due to the influx of fresh water. These changes in ocean currents can alter weather patterns around the globe. The disruption caused by the influx of fresh water has a rippling effect on the rest of the current. So if you wanted to see rising sea levels in real time, you'd want to look at places furthest away from the poles. But who exactly would suffer the most? Over 60 meters or 200 feet may not sound like much, but that's enough to cover the entirety of the Netherlands, one of the lowest-lying countries in the world. Many other countries would be partially submerged too. Bangladesh, the world's most densely populated country, with over 160 million people, would be completely underwater along with the Maldives, a tropical paradise made up of 1,190 coral islands and home to 540,000 people. Major cities across the globe would either be partially or completely underwater. New Yorkers would need to move inland as the Big Apple sinks under 200 feet of water. Likewise, Jakartanos could say goodbye to their homes as the Indonesian capital disappears under 200 feet of water. Even the Japanese capital of Tokyo would need to relocate as the world's largest urban area by population disappears under the waves. And Londoners would find themselves swimming to work as Buckingham Palace gets a new address. As the water level continues to rise, many more countries would follow suit. Major cities including Shanghai, Los Angeles, Mumbai, Manila, and Sydney would disappear underwater. And when the water finally recedes, billions of people would find themselves without a home. Over 1 billion people live in coastal areas and low-lying islands, meaning that a 200-foot rise in sea levels could make over 1 billion people homeless. This isn't just a theory either. The Intergovernmental Panel on Climate Change predicts that global mean sea level will rise by 1 to 4 feet by 2100. If emissions continue unabated, however, the IPCC acknowledges that sea level rise of more than 6 feet by 2300 cannot be ruled out. But what happens when all the ice melts isn't limited to rising sea levels and mass extinctions. A change in sea level alters the salinity of the ocean. When the ice melts, the influx of fresh water dilutes the salt in the ocean, changing its chemical composition. It also affects the density of seawater, altering ocean currents and weather patterns. The North Atlantic Oscillation, a weather pattern that influences the frequency and severity of storms in the North Atlantic Ocean, is one of the most prominent phenomena affected by changes in ocean salinity. A positive phase of the North Atlantic Oscillation brings warmer temperatures to Europe, while a negative phase brings colder temperatures. Studies suggest that the decline in the frequency of negative phases during the 20th century may be partly attributed to the reduced salinity of surface waters in the North Atlantic, which resulted in weaker ocean currents that were less effective at bringing cold water southwards. But we aren't just concerned with our own survival. The delicate balance of life in the Arctic and Antarctic regions would be completely destroyed. Many species of phytoplankton and deep-sea corals that live in the polar oceans depend on the cold, salty water for survival. These organisms form the base of the food chain and support a wide range of marine life, including fish, mammals, and birds. Their disappearance could trigger a collapse of the entire ecosystem. Polar bears would likely go extinct, though ironically this would actually help fight climate change. A single polar bear eats around 1,900 kilograms or 4,200 pounds of ringed seal each year, helping control the population of seals. With polar bears gone, the seal population would likely explode, leading to overgrazing of the plants in the Arctic Circle. Even those animals who manage to survive might not have a place to call home. Take the Adelie penguin, for example. This flightless bird lives on rocky shores and is perfectly adapted for life in Antarctica. But as the ice melts, these habitats will disappear. The Adelie penguin relies on the cold climate to maintain its body temperature. As temperatures rise, they may struggle to regulate their body temperature, leading to dehydration and exhaustion. So what happens if all the ice at the poles melts? Well, in short, we lose much of what makes Earth habitable. Rising sea levels, altered weather patterns, disrupted ocean currents, mass extinctions, and a whole lot of chaos. The good news is that there's still time to take action. The world's leading climate scientists warn that global warming will reach 1.5 degrees Celsius above pre-industrial levels sometime between 2030 and 2050. This means we have less than 30 years to prevent irreversible damage to the planet. We need to cut greenhouse gas emissions by 45% from their current levels to stay below the 1.5 degree threshold. And even though this seems daunting, it's not impossible. We need to stop burning fossil fuels and invest in renewable sources of energy like solar, wind, and hydropower. We also need to adopt sustainable practices in agriculture, industry, and transportation. It won't be easy, but it is possible.